The goal here is to verify this trig identity. So put this down onto your notes, please. Tangent x times cosecant x equals secant of x. So when we verify trig identities, we want to change the left until it looks like the right. So all the changes happen here. This stays the way it is. You know you're finished when all of this looks exactly like that. So let's begin. How about we change tangent into sine of x over cosine of x? Because in your cheat sheet over here, in your cheat sheet, that's what it tells you about tangent. Tangent is sine over cosine. Let's keep the multiplication symbol there. Now, what about cosecant? Cosecant, as you see right there in your cheat sheet, cosecant is the same as 1 over sine of x. Leave the equal sign and just leave the right-hand side. Just leave it empty. You're only going to change stuff on the left. Now look here at the left-hand side. What cancels on the left? You can see on the left-hand side that sine can actually cancel with sine. So we're left with 1 above cosine of x. That's what we're left with, 1 plus cosine of x. Equals, just put the equal sign there. Now, what do we know about 1 over cosine of x? That is on your cheat sheet. Is it here somewhere on the cheat sheet? It should be, yeah, look right there on your cheat sheet. It says right here, right there. 1 over cosine is the same as secant. So this would be secant of x equals, and now the right-hand side collapses, and that's when you're finished, when you've changed the left-hand side until it perfectly looks like the right-hand side. So your answer is everything. All of this work on the left, that is your answer. The steps that turn the left into the right. So let's do 2 more here for today's notes. Verify, so put this down. Sine squared cotangent squared plus sine squared x. All of this is supposed to equal just 1. So we make changes on the left until it looks like the right. So I observe that both terms have sine of x in common. So I'm going to throw sine squared. I'm going to throw sine squared outside as a common factor. So inside, if I factor out sine squared, I'd be left with cotangent squared x plus 1 if I throw sine squared outside. Now, looking at your Pythagorean identities, like right there, we know that 1 plus cotangent squared, which is what this says, 1 plus cotangent squared, that's just cosecant squared. So this becomes sine squared x times cosecant squared. Equals is just equals. Now sine squared on the outside stays. Now inside, what do we know about cosecant of x? Cosecant is the same as 1 over sine. So if cosecant is being squared, it would just be 1 over sine squared. And now what is sine squared times 1 over sine squared? The signs would just cancel out. You'd just be left with 1 equals 1, right? So you'd be left with 1, which equals the original 1 on the right-hand side, and we are finished. So let's try one more here today. Last one. Let's go with cosecant of x minus 1 equals 1 minus sine of x over sine of x. And we must change the left until it looks like the right. Well, how about we change just cosecant of x? We know that cosecant of x is 1 over sine of x minus 1 equals. Now, what do I do next? Well, here I have 2 terms. The answer is just 1 fraction. So how about like this? How about underneath the 1, you put a 1? Now, if you have a fraction minus a fraction, if you're subtracting fractions, you need a common denominator. This denominator says sine, that denominator says 1. So the common denominator in green would be sine. So multiply this top and bottom by sine to establish a common denominator. So we have 1 over sine minus sine over sine. So the whole point there was to get a common denominator, which we now have. And since we have a common denominator, the two fractions can be meshed together into one fraction. So sort of ran out of space, but it would say over here, it would say 1 minus sine of x over sine of x equals the original right-hand side. So we can just check that off. So when you verify trig IDs, make changes to the left until it equals the right.